In this lesson, we are going to be looking at the division of polynomials, and our main objective is to use long division and synthetic division to perform this division. So we're going to start off by actually looking at the division of numbers using the long division method. And if you recall, if we were to take and divide 277 by 12, what we would do is we would look first of all to see, does 12 fit into 2? And the answer would be no. Now we would look at the number 27, and we see that 12 does go into 27 2 times. So we would multiply 2 times 2 and get 4. Multiply 1 times 2 and get 2, 24. We would take this number, this expression, and we would subtract it from the number above. So we would go 7 minus 4 is 3. And now we would bring down the next digit, in this case 7. And then we would go ahead and ask how many times does 12 go into 37? And we would say 3. And multiplying 2 times 3, we would get 6. And 1 times 3, we would get 3. And then we would subtract that from the number above us. And we would wind up with 1. So we have here a remainder. That would be our remainder. And in fact, if we wanted an exact answer, we could say that 12 goes into 277 23 and 1/12 times. So this would actually be the answer to our problem. So just as a reminder, the number or expression that we are dividing by is called the divisor. The number or expression that we are dividing is called the dividend. And the answer to a division problem is called the quotient. Okay? So that's division, that's long division of numbers. This is a division problem as well. So here we have 2x squared plus 7x plus 7 being divided by x plus 2. So here we have a multi-term polynomial being divided by a binomial. Okay? So we're going to set this up the same way. We're going to put x plus 2 into the divisor position. The dividend, which in this case is 2x squared plus 7x plus 7, goes inside the symbol for division. And now we're going to perform very much the same type of process that we did using numbers. So we're going to focus on the first term, the x. And the question we're going to ask is, what would I have to multiply this x by in order to get 2x squared? So x times what equals 2x squared? And hopefully the response you would give would be, oh, 2x. So that is going to be the first number we put in our quotient position. And now we're going to perform multiplication of both these terms by 2x. So I go x times 2x, which gives us 2x squared. And now I'm also going to multiply the 2 by the 2x. So I go 2 times 2x, which gives me 4x. So I go plus 4x. And just like I did over here with the numbers, I'm going to subtract this expression from the expression above. So I go 2x squared minus 2x squared. That is 0. And then I go 7x minus 4x. Gives me a positive 3x. And just like we did with the numbers here, we're going to bring down our next term. So we're going to bring down the 7. Okay? And then I'm going to repeat the process of the questioning. So I'm going, well, what would I have to multiply x by in order to get 3x? And the answer would be 3. So I'll put 3 in the quotient position. So I go 3 And now I'm going to do the multiplication of both terms again by the divisor. Okay, which is our divisor. So we're going to multiply x times 3 and get 3x. We're going to multiply 2 times 3 and get 6. And we're again going to subtract this expression from the expression above. 3x minus 3x is 0. And 7 minus 6 gives us a positive 1. All right? And just as we did with the remainder, so this is our remainder here. We have a remainder of 1. Remainder of 1. And just as we did with this remainder, we're going to use this to finish our quotient. So we'll go plus 1 over the divisor. So here we want 1 over 12. Here we're going to go 1 over x plus 2. So this is our quotient right here. This is our quotient. And that is the answer to our division problem. Okay? So let's try this again. So we're going to try, we'll do the same thing here. When we do our division, there's a couple things we need to keep in mind. The dividend we need to write in standard form, and there cannot be any terms of x left undone. So here you notice we have a 3-term polynomial, and our degree of this polynomial is 3. We have an x cubed. So we're going to rewrite this dividend. This is our dividend right here. We're going to rewrite our dividend in standard form and form placeholders before we do our division. So we're going to start off with 3x cubed plus 4x squared. We don't have any x's, just terms with just x to the first, so we put one in, 0x plus 10. So you need to do that if you're to perform long division with polynomials. Okay? Now we'll go ahead and put our divisor here, and then our division box right here, and then we'll perform the process. So again, when you set this up for doing long division, you have to put it in standard form. In other words, the term with the highest degree goes first, descending order, and there can't be any degrees left out. So if you have a third degree, you also have to have a second, a first, and then a constant. Okay? So let's begin our questioning. We are going to say, what would I multiply x by to get 3x cubed? The answer is 3x squared. So now I'm going to multiply both these terms by 3x squared. So I go x times 3x squared, of course, is 3x cubed. And then I'm going to multiply negative 2 by 3x squared. So I get negative 6x squared. And just as we did in our previous problem, we're going to go ahead and subtract that expression from the one above. 3x cubed minus 3x cubed is 0. And here I have 4 minus 4x squared minus a minus 6x squared. Two negatives form a positive. So it's 4x squared plus 6x squared gives me a positive 10x squared. Okay? Bring down the next term, plus 0x. And ask the question, what would I multiply x by to get 10x squared? The answer is a positive 10x. Doing the multiplication, I have 10x squared minus 20x. Subtract that expression from the one above it. 10x squared minus 10x squared is 0. And 0x minus a minus, two negatives make a positive. So 0x plus 20x is a positive 20x. Bring down the next term, plus 10. Ask the question, what would I multiply x by to get 20x? The answer is 20. So I'll put 20 in the quotient position. Perform the multiplication. X times 20 is 20x. Negative 2 times 20 is negative 40. Subtract that expression from the one above. 20x minus 20x is 0. 10 minus the minus, two negatives make a plus. 10 plus 40 equals a positive 50. This is our remainder. And so we're going to go ahead now, and to finish our quotient, we'll go plus 50 over the divisor, which in this case is x minus 2. Okay? Okay, one more example here. So, here I have 3x plus 1, 15x squared plus 8x minus 12. This is already in standard form, so we go 3x plus 1, and we are dividing that 15x squared plus 8x minus 12 by 3x plus 1. So 3x times what is 15x squared? Hopefully you would say 5x. 3x times 5x is 15x squared. 1 times 5x is a positive 5x. Subtract. That goes to 0. 8x minus 5x is 3x. Bring down your negative 12. 3x times what is 3x? The answer is 1. So now I have 3x plus 1, and I subtract, giving me negative 13. So my quotient here will be 5x plus 1 minus, and now my remainder is negative 13. There's my negative 13 over 3x plus 1. Okay? So one more time here. I've got x minus 3. So I have x squared plus 5x minus 28. And that is being divided by x minus 3. So I have x times what is x squared? Well, that's going to be x. So I go x times x is x squared. Negative 3 times x is minus 3x. Subtract that expression from the one above. That goes to 0. Two negatives make a positive, so 5x plus 3x is 8x. Bring down the negative 28. X times what is 8x? The answer is 8. So 8 times x is 8x. Negative 3 times 8 is negative 24. Subtract the expression from the one above. 8x minus 8x is 0. Negative 28 plus 24. Two negatives make a positive. So that's going to be a negative 4. That is my remainder. So my quotient then, the answer to the division problem, will be x plus 8 minus 4 over x minus 3.